Hi guys. We're gonna see how this works. I have Commons duty, so if there's like a lot of background noise, I apologize, and you can tell me how terrible this is when I see you in class. But we are doing notes on writing equations of lines. This was not a part of your original packet of notes I gave you, so I should have given you this earlier in the week. If you were home quarantining or just weren't here when I handed out this individual sheet of notes, go to the calendar right here, click on the notes, there we go. And then you can either print this from home if you have the capability to do that, or you can just write these notes by hand because it's not like a ton of diagrams, it's more just equations, I suppose. So know that those are options for you. Okay, super slow down here. This is probably not a good sign for things to come, but we're gonna keep on keeping on. Yep, this is what it should look like. Here we go, here we go. And it's coming to a screen near you, I hope. Okay, we'll just wait here for a hot second. Beautiful, that's what they look like. Okay, so I'm gonna get rid of that. Make this larger. Maybe zoom in if I can. Okay, folks, here we go. So we are writing equations of lines. So the first useful equation we're going to work with is slope-intercept form, and that is when y equals mx plus b. So now m, remember, stands for slope, and our b is our y-intercept. So I said this earlier in the week, but I mean, this is really the bread and butter of Algebra 1. Like, if you had a good experience, this should be a nice review for you. If you had a crappy experience in Algebra 1, I'm going to go kind of fast, so I apologize, but we'll fill in the holes hopefully as we go through. So example 1 and 2 say, given the graph, write the equation in slope-intercept form. So we first need to find our slope, and again, remember, we count. How many up? 1, 2, 3, 4. How many do we run? 2. Remember, we always want to reduce, so we get 2. Our y-intercept, remember, your y-intercept is where it touches your y-axis. I touch my y-axis right here at negative 1, 2, 3. So now we just put it all together. Y equals our m, which is 2, x, because that's part of the equation, minus our y-intercept of negative 3. And that is it. Let's try another one. Again, we start with finding our slope. So remember, you start with the leftmost point to your right point. So we're going down 1, 2, 3, 4. So negative 4. How far am I running? 1, 2, 3, 4, 5. Negative 4/5 cannot be reduced, so we are good to go there. Our y-intercept, where do we touch the y-axis? Well, we touch it here at negative 2. And now we plug into our formula. Y equals our slope of negative 4/5 x minus our y-intercept. There we go. That is it. Okay. We can write equations of vertical and horizontal lines. It doesn't really look like our y-intercept form. It's a little different. When you write the equation of a vertical line, it's going to be x equals wherever it touches your x-intercept app. So here's my line. I know it's kind of hard to see, but it's going straight up and down. Now, where does it touch the x-intercept, or the x-axis? Well, it touches it here at negative 1. So that's it. X equals negative 1. Similarly, for a horizontal line, it's going to be y equals, but now you guys see where it crosses the y-axis. So there's our line here, and it touches the y-axis at what? 1, 2, 3. So y equals 3. So for a vertical line, it's x equals, and if it's a horizontal line, it's y equals. And then the other really helpful formula or equation of the line that we will use is point-slope formula. So this is when you're given literally a point and the slope of the line. I know, people in math are not very creative. So the formula for that is y minus y1 equals m x minus x1. So we're given this point x1, y1, and our slope of m. If we know those two things, we can plug into this formula and figure out the equation of the line. So let's do an example of that. If it helps you, label what you're given. So here would be my x coordinate, my y coordinate, and our m. And now we simply just plug in. So we're going to have y minus our y coordinate of 1 equals our slope of 2, x minus our x coordinate of 4. And then it says be sure to always solve for y. So yes, we need to get y by itself. So how do we do that? Well, first we have to get rid of these parentheses by distributing. So I'm going to get 2x minus 8, add over the 1 for our final answer of y equals 2x minus 7. There we go. Let's try another one of those quick together. So again, I'm going to label x1, y1, our slope of a half. So we're going to have y minus our y coordinate of 4 equals our slope of a half times x minus our x coordinate of 2. And now we distribute to get rid of the parentheses. So half x, half of negative 2 is negative 1. Add over 4, so y equals half x plus 3. Okay, so that is the type 1 kind of problem. Type 2, shimmy, 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 here we go, is when we are given 2 points. Well, remember, between any 2 points, we can find slope, so that is step 1, is we need to find our slope. So remember, slope formula is you subtract your y coordinates over you subtracting your x coordinates, and then we simplify. So negative 1 minus 7 is negative 8. 1 minus negative 3 is 4. Negative 8 divided by 4 is negative 2. So now we found our slope is negative 2, and now you get to pick what point you want to use. Just out of habit, I'll always pick the first one. So here's our point, and now we plug into point slope form. So y minus our y coordinate of 7 equals our slope of 2, negative 2, excuse me, x minus our x coordinate of negative 3. Get rid of our parentheses, negative 2x, that turns to really a positive 3. Negative 2 times 3 is negative 6. Add over your 7, and we get negative 2x plus 1. I realize I'm going super fast. I'm just trying to keep this video kind of nice and short. We will do number 6 together in class when I see you next. The next part is comparing whether the equations are parallel, perpendicular, or neither. This is kind of a nice review of our last lesson and today. So if we look here, we're just really focusing on our slopes. So our slope of this line is negative 3/2. The slope on this line is 2/3. So let's decide, are they parallel? No, because they are not the same slope. Are they perpendicular? Are they opposite reciprocals of each other? Well, this one's negative, that one's positive, so they're opposite. And they are flipped, right? 3, 2, 2 over 3. So they are indeed perpendicular. All right, this next one, we can't easily tell what our slope is on this first equation because y is not by itself, so we need to get y by itself to do that. So let's subtract over our 3x, and then we can't have a negative y, so all of our signs are going to change because we're dividing by negative 1. So now we find that our slope is 3. Our slope of this one is 1/3. So now if we look, are they parallel? Do we have the same slope? Nope. Are they opposite reciprocals of each other? They are reciprocals, but they're both positive, so they're not perpendicular, which therefore makes them neither. Okay, So now putting all this together, we got to piece everything we've learned in order to do this last part. It says write parallel and perpendicular equations. So write an equation parallel to y equals 2x plus 4 that passes through the point -4, -1. So we need to steal something from this equation. If I want my line to be parallel to this line, what does our slope have to be? Well, our slope would have to be 2. And now we're going through the point -4, -1. And now we have our point and a slope. So now we can plug into point slope form. So y minus your y coordinate equals your slope, x minus your x coordinate. Now we got to get y alone, distribute that 2, so 2x plus 8, subtract over your 1, y equals 2x plus 7. We will do this in class together. Let's skip down to the third one. It says write an equation of a line perpendicular to y equals 3/4 x minus 1 that passes through the point 3, -3. So very similar. We have to steal something from this equation. If I want my line to be perpendicular to this, my slope would have to be what? We're going to flip it, so 4/3. Since this one's positive, it's going to be negative. And we're going through the point 3, -3. Now again, plug into point slope form. Y minus our y coordinate equals our slope, x minus our x coordinate. And now we distribute. -4/3 x. Okay, so now let's think about this, folks. -4 times a -3 would be 12/3. So if we simplify that, we're going to have y plus 3 equals -4/3x. 12 divided by 3 is just 4. Now get y alone by subtracting 3. There we go. Y equals -4/3 x plus 1. And we will finish up that last example in class together. I hope we kind of dusted off some dust in your memory bank of how to do this. If this was totally new for you, let me know and I will work individually with you to kind of get caught up. Have a super rest of your day and I will see you when I see you.